Consider the complex equation z to the n minus 1 equals 0. So z to the n equals 1, where n is any positive integer 3 or greater. If the roots are designated as z0, z1, z2, and so on, determine the exact value for the product of the roots. So we have z to the n is equal to 1, which we could write as cis m pi, where m is a natural number. Now, I've used m here because we've already got n, so I'd normally use n here. So, sorry, it'd be 2m pi. So we know that one of the solutions is here at 1, and then it's every time we get around there, so that's why it's 2m pi. So z would be equal to cis 2, I don't know why I'm writing 3, 2m pi divided by n. So let's think about some of these. So z0, we could just say is the cis 0. z1 would be cis, so take m as 1, 2 pi over n. z2 would be cis 4 pi on n, and so on up to z n minus 1, which would be cis 2 n take 1 pi over n. So if we multiply these together, so we're multiplying them, then what we get is cis 2 pi by n plus 4 pi by n plus 6 pi by n, and so on, up to 2 n minus 1 pi on n. So we've got a common 2 pi by n which we can take out of there, and then we'd have 1 plus 2 plus 3 plus and so on up to n minus 1. So what we have in here is an arithmetic progression where the first term of 1, a common difference of 1, and n minus 1 terms. So the sum of n terms we know is n over 2, 2a plus n minus 1 d. So the sum of these n minus 1 terms would be n minus 1 over 2, 2 plus n minus 2, which gives me n minus 1 over 2. So this thing over here will be cis 2 pi over n minus 1 over 2. So those 2's cancel, the n's cancel, and we end up with cis n minus 1 pi, which is cos n minus 1 pi plus I sine n minus 1 pi. Now it doesn't matter what n is, the sine of any number of times of pi is 0. So it's just going to be cos n minus 1 pi. So this is going to be 1 if n is odd, because then you'd have things like cos 0 and if it's 3, cos 2 pi, and so on. Or -1 if n is even.